What's up, you guys? So I'm gonna talk a little bit about some concepts. They may sound very simple, but and redundant, but I'd like to go over them because I noticed that students have trouble with these concepts at higher levels of mathematics. So hopefully, to clear it up now, these students can be prepared for higher degrees of mathematics. It's essentially dealing with square roots because these guys can be difficult sometimes, right? So say if I have x squared equals to 9, right? And I'm going to compare that with x cubed equals to 8, right? Okay, first of all, we know mechanically how to solve these things as we learned in class from our teachers, right? We take the square root of both sides, x equals to plus minus 3, right? Now, cubed root of both sides for this one, right? And then we simply have x equals to 2. Now, notice the difference besides the actual values themselves. Check it out. Here we've introduced a plus or minus. Here we simply have 2, right? Not plus or minus 2. Why? What's the difference? And this is where students have trouble and usually kind of get flabbergasted or befuddled, thrown off course, deranged, derailed when it comes to these types of questions in an exam. Okay, here it is. This equation, x squared equals to 9, what this is essentially saying is that what number can I plug in and substitute for x that's going to give me 9 and make this statement true? Well, we know that by solving it mechanically or strategically, we have plus 3, right, and negative 3, right? X equals 2, and that works. 3 squared is simply 9, and negative 3 squared is also 9, right? And by the way, one thing I want to know is negative 3 quantity squared is 9, right? Not negative 3 squared. This is not equal to 9. That is negative 9, right? This equals to negative 9 because you're only squaring that negative 3. That 3. I want to also make that clear. Note this. Note it. Make sure you guys know this. I had a few students who had kind of blundered at this area. They forget the rules, right? So anyway, I'm going to erase this. Going back to this. So we understand that this equation is valid for two different numbers or two different values, right? Positive and negative 3. Now, however, this one we can't essentially do it like that. We can't say that. Let's try it. Let's try to put negative 2 in there, right? So if we said, well, 2 works, and we know that 2, we're saying 2 times itself 3 times equals to 8, which is a valid statement. But what if we plug in negative 2? Negative 2 cubed, right, does not equal to 8. Why? Well, we know that negative 1 cubed times 2 cubed, right? That's what this equals to. And negative 1 cubed is simply negative, and 2 cubed we've already determined is 8. Simple stuff, but the concepts can be very, I guess you could say, difficult to understand at certain points because these things get dramatically harder, especially when they're put into larger polynomials and expressions, and then you're asked to solve for certain aspects of or certain values, and then also on top of that, when they're put into rational expressions and you're asked to find the domain and ranges and everything, that's where these things come into a great deal of play. But to understand at this level may save you a lot of hassle in the future, right? So again, we get negative 8 if we plug in negative 2 cubed. So we can rewrite this if we want. So x cubed, right, equals to 8. And I'm going to solve. God, I write horrible, you guys. That was my biggest. Everyone's been. The only complaint I get is that I write really bad. So bear with me, you guys. So anyways, we can solve it again by taking, strategically we can solve it by taking a cubed root, and I'm going to show you. Cubed root, right? So x equals to cubed root of 8, x equals to 2, right? So what if I said x cubed equals to negative 8? We can do the same thing, cubed root of both sides, and then cubed root of negative 8. And then I'm gonna throw in another rule from way back when you have a times b, right? Your square root or cube root, any root times, say this, n root n to the a times b, or yeah, that's how you would say that. We can separate that times n to, right? That works. So we can do that here. We can separate 8 and -1, right? -1 times cube root of 8. That's what we essentially did here, right? This is a, this is b, and we put them both under the same cube root. Now, and we could solve them separately, work with them independently. What's the cube root of -1? Negative. And then cube root of 8, 2. And then we just multiply them together and you get -2. That's, I guess you could say, a very, this might be a redundant aspect, but again, I see this arise and emerge as difficulties in so many different students, from actually in all the different types of work that I do, from in different districts. I see that students fail to really understand these deeper aspects because they're so used to thinking mechanically or strategically according to how the teachers have taught them to do it. But I want you guys to understand the conceptual aspect, and that's my point here. So yeah, that's a really cool way. Think about it. Another thing I want to mention, and this is a little bit more of a strategic approach, I'm just going to bring in another rule, is that look at the degree on the variable. It's even. Do you guys agree? Even, which would be 2, 4, 6, 8, or it goes on, right? In this case, we have 2. For the one on the opposite side, we have odd, right? 3. In this case, 3, be 5, 7, 9, and it goes on. If the degree is even, then you're going to introduce the plus or minus, but that doesn't work for the odd. That doesn't work for the odd, because even if I have x to the 6th, right, and we were to just hypothetically, if we were to plug in a negative value to that x, right, well, negative 6 times, or a negative number times itself 6 times, 1, 2, 3, 4, 5, 6, it's even, right? We're going to get two negatives equal to positive. Right here, the same, right? And we have that the same, right? So you result with a positive number. Any even number degree stands for this. Now, or this stands for any variable with the even degree. But if we have an odd, right, x to the 7, where we said that a negative number times itself 6 times gives you positive, but then let's go ahead and just arbitrarily add that extra negative, so we have 7 of them. Well, if this is all positive, then you've added a negative, or you've incorporated a negative, and then you have a negative result. Do you see how that works? So yeah, that's all I really want to say in regards to this in this video, this aspect. Again, I'm just trying to get you guys to think about it in more of a realistic aspect as opposed to just more strategical and mechanical, because again, it helps you in the long run when you're faced with these types of questions with in different aspects, and then you can know how to work them out and thoroughly. That's going to get so you can ensure yourself that you can have the right answer, right? Because I mean, hey, teachers like to mess with students, and they like to know that you know this stuff. Anyways, I'm going to leave that here. I'm going to go over in detail some other aspects of today's lesson that I had with a student, dealing with domain and ranges, and then incorporating these guys into rational expressions, and then finding the domain and range. Thank you. See you guys later.